Welcome to our Fireside Chat. This is the TVOT Live. We're very grateful to be here this Tuesday, April 27th. I'm Chris Pfaff. I'm the CEO of Chris Pfaff Tech Media LLC based in New York. And we're very, very, very fortunate to have Jerimiah Hamon, who is the chief scientist of Firstlight Media. Of course, is a sponsor of the show, good friends. And for those who don't know, and you're going to learn, a true personalization and engagement OTT platform. So let's talk about chief scientists. And I've worked with a lot of chief scientists over the years. But, you know, machine learning and AI, particularly in video and audio, has, I think, to a lot of people in the industry, been commodified to some degree. But it's really good to talk to somebody who has your background. And for those who don't know, and we're going to start with this, you are, among many other things, an econometrician. So how did an econometrician get to this position in the OTT industry?
So appreciate you having me. Thank you. And so econometrics has sort of become the catch-all, be-all for applied math-based computer science. So there's two big paths you can go down. One is you become a computer scientist who's going to rely on applications to solve for an outcome, whatever that be, through AI, ML, deep learning, whatever the choice is. As an economist, you learn to use math to define what human beings will do in a given situation. What do people do? Ergo the economics. And so what we're doing, and I'm not the only one, Amazon has a team of several hundred economists. So it's not unheard of. Essentially what we're doing is sort of a psychometric evaluation where we're trying to figure out what is it that pulls people into or drives people away from a product, content, advertising, whatever that thing may be.
So how does what you do differ from data science? Because, of course, that's another title that people are familiar with. But with respect to what you do and have done as well in terms of predictive analytics for video, talk about the difference between sort of data science and what you do.
So data science is kind of, everyone knows it's a fairly new term even. I remember 6-7 years ago not knowing what it was. Before this, I was, 6, 7, 8 years ago, I was either an econometrician or advanced analytics. And so data science is that marriage between computer science, applied math, and statistics. And so a lot of people will come out of, computer scientists come out of school with, a bachelor's degree, or sometimes a master's in computer science, and then they have wonderful software development skills, and so they solve the problem through the use of a really fast widget, if you will. And then you have mathematicians who come in, and they want to always build an equation that explains what's happening, and then they want to put applications afterwards to where you take that learning around the math and then push high volumes of data through it. As an example, when I was in college a long time ago, we could only handle very small regressions, like a few thousands or 100,000 on the servers that we had at the University of Arkansas. So nowadays, though, I can run through hundreds of millions on my laptop. So data science is basically that enablement, the ability for computer scientists, advanced computer scientists, entry-level mathematicians, and a lot of people who you wouldn't think of as data scientists, biologists, physicists. Physicists make wonderful. My partner over here, Alexa, had an opinion on that. They make great data scientists. Sorry, I lost my train of thought.
You're talking about, again, physicists. And again, I think anyone in the technology field will hire you if you're a good physicist, and sometimes they're harder to come by. But you had told me a story once that I love, and I'd love for you to repeat, about talking about econometrics when you were talking with Bob Sherwood years ago at Disney, and and sort of what where we've come from, say, 10, 11 years ago to where we are now with respect to that field of study and application to the industry.
So Ben Sherwood, Bob Iger, Ben Sherwood. So Ben was the at the time when
My
I was
bad.
at Disney. He was no, that's fine. I just want to give him his credit. He was the CEO of Disney ABC Television Group, and he had found out that there was a new econometrician, and that's actually what he majored in college also, or one of his majors, I think, was also journalism. And he invited me to his office for these like bi-weekly or however often they happened meetings, just to talk about what was I working on. I remember sitting in there one day, and I was he had a really small whiteboard, so he had to write small. So I was writing out what I was doing in econometrics to solve for certain content consumption on the Disney ABC television platform. And as I was going through it and describing it, he just paused me for a second and said, I remember those words from college. I remember hearing them, but it doesn't stop me from every time you say it just wanting to throw up in my mouth just a little bit. And I was like, okay, that's awesome. And then we kept going. But he was actually quite brilliant. He's a brilliant man. So it was fun.
Yeah, I think that level of regurgitation, has yet yielded some fascinating innovation. You, of course, had worked at Amazon around the time that PII was really kind of coming into the fold, maybe 10, 11 years ago. It's incredible to think where we were then and where we are now. And I think that's probably a good opportunity to talk about how you got connected to Firstlight Media and obviously what the mutual attraction was.
Well, I think Firstlight it's really unique in the space. And when you talk about media and content, there tends to be a sort of a cash cow methodology where people just want to make bounds and bounds of money and use the cheapest technology to just make it run. Just make it run. And they don't spend money on maintenance. I mean, I've been to pretty much every major studio in Hollywood and in other places, and they just want to keep that thing running. So they might be running, I'll use an analogy, a Model A Ford when they could go out and buy a new Ford and it would just work better, but they don't. Firstlight takes the assumption that we can make it better, and by making it better, we mean we can use the best technologies, the best of breed coding, the best of breed methods to develop solutions that are going to be long-lived. Instead of something that's just going to work for 1 or 2 years, like an HTML or HTML5, you're going to write something that's going to last for hopefully, ideally, a decade, but I think that's being a little overly optimistic. But by using that methodology, we're able to use things like Kubernetes, cloud native, software as a service, things that make the service really expansive, the ability to basically be in any country, in any language, running, massive sets of data through it in almost real time in many instances.
And this is interesting because, of course, I know that you have a linguistic background, and we've talked about where localization comes in with the explosion of OTT, and particularly with globalized niche channels. Talk about how Kubernetes works with that in terms of really compacting the data streams, because it seems like you and your team at Firstlight Media are really onto something new that makes a big difference for these levels of personalization.
So I think if you think about it, in the old days, and I'll show my age a little bit, but when I first started writing programs in a thing called BASIC on an Apple IIe, I believe it was, and then we went
right
on
back here.
Yeah, exactly. So the Stone Ages of computing. And then moved on to mainframes and then eventually Unix servers. You were processing hundreds of thousands of rows not simultaneously, but in a thread. You would run them all through the machine. In Kubernetes, you're basically able to break it down into manageable chunks where you're solving each small piece simultaneously. And so if you have 1 + 1, 1 + 2, 1 + 3, 1 + 4, in the old days, you would have to add those up sequentially pretty much. You couldn't do like hyper-threading or multi-threading. With Kubernetes, it's basically the ability to expand into the cloud to where you're able to run all of these simultaneously if you need to, or maybe you have an optimal solution set. I want to solve 5 of these simultaneously. So you run 5 CPUs that are going to generate that answer for you and fill it in. So what does it mean? It means that you can have the ability to bring in massive amounts of data, process them near real time, And the cost efficiency is not that different from just, well, it's way better than having on-prem 99 times out of 100. But in general, it's just the efficiency is where you make gains. It's efficient, it's reliable, and it's very scalable.
So yeah, leveraging those capabilities of the cloud, I think also get you into really almost new levels of monetization. And you and I have talked about sort of your view of all this, and you've compared some of the constituent parts of content to baking a cake ingredients. Talk a little bit about that.
So it's interesting. When I first started as an econometrician, fresh out of college, you still smell the textbooks on my breath. I would be building all the models on a piece of paper, literally, drawing it out, and then kind of trying to work my head through how it would solve. And then I would try to figure out how to push data through it. And so now, in 20 years later, we actually take the data and we look at the data first, and we work through it to figure out what are the ingredients that are in this thing. So let's take a piece of content, say a comedy. We can break the comedy out into all of its constituent parts. How many jokes are there? What's the run rate? Who's on the screen? How long are they on the screen? What did they say? Are they happy? Are they sad? So all of these ingredients lead to an emotional picture that we carry in our minds as we watch the content. And the level of that emotional picture as it's going up and down, laughing, crying, whatever your reaction may be, those ingredients add up to, I love that show. I hated that show. And it equates to just like cake, because, I used to do a lot of baking when I was a kid. And I'd always use the all-purpose flour instead of the one that's not all-purpose. And you don't have to add salt to that one. Anybody who bakes knows that. I didn't know that at 8. And I would constantly add salt to my cakes because it always called for 1 teaspoon, and just absolutely ruin the whole thing. And content's exactly the same way, and content delivery is the same way. Advertising is the same way. Too much of any one thing ruins it, and the fastest way to figure that out today is to actually just film it, watch people using it, somehow gather data on how they're using that item, and then you're able to explain, oh, you know what? There's too many jokes in this comedy, which I know sounds crazy, but it is the case. You can have so many jokes in a comedy that it becomes exhausting. People have to have a break. Consumers, viewers have to have a break. A joke here, rest 1.5 to 2 minutes. Another joke, rest. And the same with dramas, romance, whatever. They each have their own cadence and tempo.
Yeah, we've talked about where heuristics is in terms of video AI in the industry, and we've talked about some other players who we know, and some I've certainly worked with, but it seems that you're applying that model, as you said, trying to mathematically prove or use some learning to build this into the model that you've created. And so it begs a question, because I think that you guys are really onto something. What are you working on now that you can disclose or are comfortable disclosing that you think would most likely be really a game changer for the industry?
Well, I think the industry has struggled, for many years without any sort of treatment for it. But recently you hear a lot of these discussions around determining the genome for content. And essentially, you could say it's exactly the same as the cake analogy. You're trying to find out what are the parts that make up content that make it successful. And then you want to understand from the consumer side, what parts of it do you like? So maybe you don't like cake with chocolate in it, or maybe you don't like vanilla cakes, or whatever it is. Maybe you don't like romance with too much kissing, or maybe you don't like laughter with too much violence. And we all have these predilections that we choose to watch things because they satiate something inside of us the same way food does. Content is just food for your mind, and one could even stretch it and say your soul. And so what we're doing is building that ability to break the content down into these very minute constituent parts, and then learn from these very aggregate, large populations of people who will consume content. I'm a bit of a militant on the PII data. I don't think you need the data. You don't need the identity of people. You don't need really anything about them. In fact, I don't want to know anything about them. And I think that's I've noticed that's becoming really common in data science, because we all have this fear that we're going to be the one who gets in trouble. And then we also have this fear that we're going to be the one who's exposed. Because when you start thinking about the volumes of data going through Google and Amazon and Facebook, I forget how many was it, 50 million people exposed a few weeks ago. That's staggering.
I thought it was 500 million.
Oh, it's 500 million. I'm sorry. I missed the zero.
10. Yeah.
Sorry. Yeah. But yeah, that's just staggering. But when you think about how do we lead the industry, how do we change the industry, it's about being able to break the content down into its constituent parts, understand the consumer's desires, and then give them that thing without intruding into their lives, because you don't have to. It's unnecessary, in fact. So I think in that way, I think we are out in front, way out in front, in fact. So.
It's, just to get back to Amazon for a second, of course, they had a big announcement recently within the last, I guess, 6 weeks about their intelligence suite. I can see what you're doing, among other things, really serving a lot of people in ways that aren't intrusive, because, of course, you and the team really come from the content, industry. Not that others don't, but quite frankly, you do have an advantage there. But it begs the question about what other people have done, and we're not here to dunk on anybody, but when it comes to data, I mean, what are some common mistakes that people make when they're trying to approach this industry from a data perspective?
I think there's one mistake that's made, and it's not just in this industry, it's in every industry. People, it's funny, I often make the joke that I haven't applied for it. It's 95% true. I can think of one job I did apply for, but most jobs, somebody calls and says, hey, we got this problem, we can't seem to solve it, do you want to come try? And I'm like, let's do this. And so the thing that I see that it's ubiquitous is that a lot of times, and I hate to say it because I feel all the data scientists just hating on me, is that just because the application runs and just because it creates an answer doesn't mean it's right. And so I think that's what separates the way I approach it and my colleagues and the people that I consider peers. We don't just accept that it's right just because it ran. Validation is 95% of the battle, and cleansing the data and ensuring that you can prove that, oh, this answer is right. Well, let's prove it from this side. Now let's prove it from this side, and this side, and this side, and this side. And then I go, you know what? That might be the right answer. Because the math doesn't know, and for sure a computer program doesn't know. It won't know until a human being gets in there and says, yes, I agree, these are all correct answers. These are all incorrect answers. But it takes that human touch, willingness to dig in and look at the data. I get on these kicks where I want to watch data science videos because I want to see how other people are solving problems that I already have a way to solve.
And which data science? I mean, are you going to YouTube to see lectures, or would?
YouTube. I forget the one. I have a subscription to one of them. I forget what it was. They gave me a free subscription, so I watch their data science videos a lot. And one of the things that I've noticed as a trend is that as they're teaching you to do data, so they'll teach you in, say, Python or R or something, here's how you ingest the data, here's how you view the data, here's how you build this analysis, this analysis, this analysis, and then here's your final output, good to go. One of the things they don't teach, they'll show you, look, we can import a table with 100,000, or we can import a data frame with 100,000 or 100 million rows, and they can go all the way through it. The one thing they never do is look at the data, which is, for me, mind-boggling. Like, anybody who has a math or statistics background is always boggled by that. It's kind of like the example I love is that if you take Bill Gates, what's his name, Elon Musk, and Jeff Bezos and Jerimiah Hamon, on average, we're billionaires. If you add up all our salaries and you divide it, we're all billionaires. But it's not true, obviously. And so when you take a data set and you pull all that data together, essentially at some level it's aggregating it. And if you aggregate a whale in with the minnows, then you're going to either have minnows the size of, dolphins. It just doesn't make sense. It's completely illogical. But a pure computer science method won't catch that unless there are ways to do it, but I just don't see them being taught.
That I think that's a that's obviously going to have to change, because when it comes to machine learning and how images are processed and how things are predicted. I mean, we talked a little bit about the predictability of monetization and where things go in terms of ratings, like Nielsen. I mean, we're looking perhaps at some very old ways of looking at content. I think most people, think of as we've also discussed, what content mix. I mean, you can learn a lot by knowing how many car chases might make at what at what scene and what act, how many aliens, et cetera, et cetera. I mean, this stuff is actually quite meaningful now. Not that it wasn't, let's say 50 years ago, but now it's incredibly meaningful, particularly, if you're trying to sell against that.
Well, I mean, you're exactly right. You can break content down into how many smiles does Tom Cruise make in this piece of content? How many frowns does he make? Do I see his backside? Do I see his front side? Do I see his hair? Is his hair combed? Is it messy? There are all these different variables that come out of it that we as human beings, we don't think about it. I mean, even I didn't think about it 10 years ago or 15 years ago. But now that I'm in this space and I look at it, it's like every time something happens, and then I think back to, conversations that I've been exposed to with Spielberg and, Jeffrey Katzenberg and some of those really big names. And they literally watch every hair on a head, it seems. Like they know how somebody's blinking. They know how they're holding their mouth. And they're always giving them those really specific directions. I'm like, wow, that's crazy. But then when you go through and you analyze the content, you're like, oh, yeah, and that's why they're so successful. That's why they make it, because you do have to have that eye for it.
But that's when it comes down to the nub of what people recognize. I always found this really interesting, and this is separate but related. I always found that in terms of looking at a piece of content, viewing people's comments, particularly on YouTube, it's amazing. And of course, a lot of this is contextual. It's the contextualization of content. But what people notice and what they take away always cracks me up, because we live in this rather rapid response universe now, where, as you said, a hair out of place might suddenly become a meme. It might spur who knows what in ways that would have taken a long time. And it's all relative, right? From that, particularly from a visual standpoint. That's just another level here, but it also gets into issues of like sentiment detection. I'm curious what you think of that. You talk about how your path to where you are now is. I mean, how much do you get into that, and what's sort of your take on how that plays into what you're doing?
So in another life, I used to work for a really big software company in Redmond that made a really popular video console called an Xbox. And we did mountains of analysis, and they still do it. And it is PII. They don't need to look at you. In fact, it's when you think about the volume of data that goes through the Xbox system daily, they don't have the ability to. I mean, they could build it out, but there's no reason to build it out. But when we can look at, whenever you're in the game playing, and it's the same as watching content, when we can measure how fast you can push the button, how quickly do you move left, how quickly do you move right, we can then. So it's basically the cycle of a stimulus and a signal, or signal and action, however you want to break it out. And so when you do that, you can get down to the most minute detail of it. I think for me, sentiment analysis specifically, I've taken it two ways. One way is that we measure the emotion of content viewers in studio settings, where we bring people in, have them watch content, and then we measure them emotionally, as opposed to, if you think about Nielsen and what they call the pulp rating method, where they bring people in, they have them watch the content, and then they ask them, how much did you love that scene? Did that scene just make you want to cry? Are you in love with Tom Cruise? Don't you want to watch more of this? And so by having these really poorly designed surveys, they end up with these really biased outcomes, and that's how shows get made that shouldn't have been made in the first place. But by using the computer, it doesn't matter how many people you put in front of it, it measures them all identically. And so then it can predict exactly how it's going to be consumed. And so doing that, you can also flip it around, and you can take the content you're looking at, pick any piece of television, and you can listen to the words that are being spoken and measure the emotional engagement that actor is putting into what they're saying. You can look at their faces and measure how much emotion they're emoting as they act. And so when you do that, you can then solve this really complex equation that comes back and says, here's the emotional reaction to this stimulus. So you've got the stimulus and the payload. What did they take away? And so by doing that, you get into these really crazy accurate. I remember years ago, I was asked if I could predict the Nielsen rating. At the time I was asked the question, I didn't know what the Nielsen rating was. And so I was like, maybe, I don't know. And so we built models. And we got to where we could predict it, more than 95% accurate. And I remember an executive, we predicted something for him on a piece of content. I emailed him the results. And so he got them, I think he got the email result in April. The content went live in October. And we predicted the rating of it in Nielsen terms to like the 4th decimal, which that was a fluke. Let's be honest, that was a fluke. Anything above 95% is a fluke, in my opinion. But he reached out to me and he asked me how I changed his email. I said, what? I sent you an email. How would I go back in time and change these? But that's how disturbing it is for the industry to see predictions like that. But the thing is 10 years from now, it's going to be the norm. 100%, it will be the norm that anyone who wants to have that level of precision and prediction will be able to do it. It's available now, but there's the barrier to entry is one is technology, and then two is sort of the ability, the training to do it. And so, but there are people who can do it.
Was that in terms of the data set or the models, or when you talk about that barrier in terms of
I don't think it's the data set or the models. Honestly, it is the barrier that lives inside of us. As a species, we tend to not want to see things. And so there are a lot of these things that I've done when I'm trying to explain it to people. Even, I met with the chief economist at Microsoft one time, and I was going over one of my models with him. And we spent, it was funny because we went to a coffee shop in Redmond. We're sitting there, and he's reading through my paper, and he's reading through my paper, he's reading. And I thought it would be like 30 minutes, and he'd say, yeah, it's cool. Or no, it's terrible. He read for 2 hours straight, and I'm like on my third coffee going, what's up, dude? Finally, he finished it, and he looked at me, and I was like, dude, is it that bad? And he's like, no. He said, it's fine. Your math's fine. It all works. He said, I just have one question. Why would you do it this way? How did you even think to do it? This doesn't make any sense. You've taken apples and oranges, mixed it with a steak, and then you put coffee in the middle of it. It doesn't make sense. And I said, I know it doesn't, does it? And I can't tell you why I did it that way, because I think it was just trial and error, discovery, and expansion. And yeah, and I think that is the barrier to entry. But in 10 years from now, machine learning and AI will overcome that barrier because it doesn't have it. And some brilliant computer scientists will be able to map that neural net to where it just makes that decision for us. And humans don't have to make it. So.
And I think that you talk about something that's unobtrusive. I mean, the idea of something that behaviorally we could maybe accept or find a way to work with, I think is, we talked about the happy path, right? And I think, in the last minute we should just briefly talk about that, which is essentially when something works because the data is perfect. But, you're looking for something else that and I think you've hit on it. What is sort of your, goal, the opiate of the econometrician here with Firstlight? What is that for you?
Well, that's easy. That's whenever we have recommendations for consumers, and that first thing, they click on it, they watch it to completion. And the next time they want to watch, they watch the second thing and the third thing and the fourth thing, because that means that we're in tune with that consumer. We're in tune with what they want to watch and what they want to get out of that experience. And then the backflip to that is we can go to the content provider and say, you know what, here's your library. You need this, and this, because people are searching for this and you don't have it. And two, because they've watched all of this, that means they want to watch this, this, and this.
Fantastic.
You don't have that in your library. So you should think about expanding your library in that way. And the other one, you've got all this content in your library, you're going to need to think of a way to market it. And we can do it, but that's a more challenging.
Well, I'm going to have to stop you right there, and because that will be the marker for the next conversation that we have. Jerimiah, I could talk to you for hours and days, and we only had 30 minutes here. I hope everyone enjoyed this. Again, so lucky to have Jerimiah Hamon, Chief Scientist of Firstlight Media. Thanks to Tracy Swedlow and the TVOT Live team. I'm Chris Pfaff. We will see you again soon. Thank you.
Thank you.